Okay, in this video I'm gonna talk about hydrostatic pressure. There are a lot of pressures, but hydrostatic pressure is one of the most important pressure. And before going to the hydrostatic pressure, I wanna talk about the pretty basic about the pressure, the definition of pressure. So basically the pressure is force divided by area. And the implication here is even if you use a same amount of force, if you have a smaller area, the pressure is going to be higher. You can imagine that, for example, I have this pen. This is pretty sharp. And if you place, for example, your finger with this pen, it's pretty painful. But if you use this side, which has larger area, and even if you use the same force, it's less painful. This is because the pressure value is much higher if you use this smaller area. So the idea itself is pretty easy, but the calculation could be complicated. And in order to stay out of trouble, I really recommend you to use these units every time: kilogram, meter, second, Newton. This is important to stay out of trouble. And if you use this number, the pressure unit is gonna be PA, standing for Pascal. And there is a basically important important things about the hydrostatic pressure. So basically hydrostatic pressure is a pressure in fluid, and pressure from the fluid media depend only two parameters. One is density of fluid, and the second one is distance from the surface of the fluid. This is pretty important, and only like one equation to remember, which is the pressure, hydrostatic pressure, always equals to rho, which is density, h, which is distance, and g, which is gravity value. And usually it is 9.8 meter per square, or some professor likes to use 10 meter per second square. So you better make sure which value you should use. But basically this is all you have to remember. This is pretty simple equation, but then you can basically calculate the hydrostatic pressure. It's pretty easy, so let's solve a problem with only this knowledge. Okay, so the problem here is like the total pressure of the bottom of the cylinder container. So we have a cylinder container like this. That is open to an atmosphere. So on this side is open and has a cross-sectional area of 29 area equals to 29 centimeter square. And again, I said, I really recommend you to use meter, not centimeter. So let's convert it right now. So 29 centimeter square equals to 2.9 multiplied by 10 to the negative 3 meter square. And now at the bottom, the pressure value is 116 kilopascal. So here you have some gasoline, And let's say that there are like h depth, and this pressure value is 116 kilopascal. And again, I like to use this Pascal, so let's multiply by 1000, which is going to be 1.16 10 to the 6 Pascal. No, this is 5 10 to the 5th Pascal. And now we have to determine the depth of gasoline. And so of course you want to use this equation. You have to know the density of gasoline, and now actually here we can use the density of gasoline. Low gasoline equals to 750 kilogram per meter cubic. So using this density, let's solve this problem. So basically the pressure equals to low, which is this one, 750 kilogram per meter cubic, and h is not known, so let's say h here, and g is again, for easiness, let's use 10 meter divided by square, now second square here, so let's use 10 meter second square, and this p value is this one, so equals to 1.16 10 to the 5th Pascal. And then what we wanna get is this h value, so you wanna bring this into this side, bring this into this side, so h equal 1.16 10 to the 5th divided by 750 multiplied by 10. And maybe you wanna use a calculator, but if you divide this one, basically this is going to be 4, and the answer is going to be 15.47. When you use this unit, you always get the answer using this unit. So this is going to be a meter. So this is the answer for A. So it's pretty easy, right? And for B, determine the pressure at the bottom of the container if additional this amount of gasoline is added to the container. So basically by adding this additional gasoline, you're gonna have additional height. So let's say this is delta H, because delta means the addition. So and using the volume equal area multiplied by distance, this equation, you can get this delta H value, since we know that area value here and volume value here. So delta H equal V divided by A, and you want to also always make sure that the unit is meter, so this is good. 0 multiplied by 10 negative 3 meters cubic. And now you have to be careful not using this one, but using this one. 2.9 multiplied by 10 to the 3 meter square, and you can cancel it out, and this is also cancelled out, and the calculation is gonna be a little simpler. 2.41 meter. And here, what we have to determine is the pressure at the bottom after adding this amount of gasoline. So now the total height is addition of original H and this delta H. H total equals to delta H plus H. Basically, you just wanna add these two, so 17.88 meter. The reason why we wanted to know the depth is because we can use this equation again. So in order to obtain the P after addition equal this law, it hasn't been changed, 750 kilogram per meter cubic, and new, and now you want to put H here, right? The new H is this one, 17.88 meter, and you want to multiply by this G, 10 meter. These are a little complicated calculation, but in the end you can calculate like 134,100 Pascal, and this is a solid answer, but just because they use 116 kilopascal at first, maybe we wanna adjust this one as well. And if you convert Pascal to kilopascal, you wanna divide by 1,000. So the right answer is going to be 134.1 kilopascal. So this is the answer for B.